I'm Tom Cottle, and I'm the owner and general manager of Four Hills Designs. And Four Hills Designs is a electronics design and manufacturing company, and we own CNC Electronics. We're here because we've been asked by a client to evaluate and upgrade a table that they recently bought. We're going to go through and look at what needs to be done to this table in terms of upgrades, what we need to do. We're going to upgrade the electronics package on it. We're going to upgrade the performance of the table, and we're going to point out the areas that need to be addressed as we go through this. The table was brought to us because it just did not perform to the level that the customer needed it to perform in a commercial application. We are going to go over what we're going to do with the gantry in terms of changing the performance of that, changing the whole structure of the way this thing is put together. This particular base is constructed of steel, welded steel, heavy duty. Finish is good on it. The welds are very good on it. In this particular gantry design, what the design team has done is they've moved the motors on the gantry up high, and they've used a system of pulleys, belts, idler wheels, and other mechanical parts in order to be able to transmit the power ultimately down to the rack. That one motor, it transmits its power through the gantry through a shaft to the center of the gantry here. There's another system of belts and pulleys and idlers that drives the other side of the table. On any of these gantry designs, it's a really good idea to drive both sides of the table, because especially on a gantry this wide, you'll get a whole lot of racking if one side is driven and the other side is just following along. As you look here and look down the side of this design, one of the things you'll note is there's not any real bearings and rails here. There are roller bearings they're actually running on angle iron. The only thing that keeps these bearings down on that angle iron is underneath. There's a drive sprocket. We call it a pinion gear. The pinion gear, of course, is driven by all these belts, but it has an adjustment, and it's pulled up against the rack, and that keeps the gantry down. It doesn't keep it completely down, because if you get it too tight, then you get binding, and it's not precision enough going down that you can tighten it all the way down. There's no spring or anything in any of the system, so it has to be a compromise in terms of the way that that's set. Here's what we're going to use for rails. This is basically 3-inch wide, 1/4 inch thick, cold rolled, which is very flat, very even. The width on here is real constant. These are adjustable roller bearing carriages. You can get them in two different sizes. You can get them in the short or the long. The long we're going to use on the sides. The short we're going to use as the cross axis to mount our Z on this. So these are adjustable. They have 6 bearings, and they roll up and down this real nice. This is a mount for a motor, and it's a gear reduction box. There's not really gears in it, it's belt driven, but it's got a 3-to-1 belt reduction on it. This will give us perfect speed versus torque reduction for our long axis, and we'll have one on our cross axis too. Because the other gantry wouldn't fit with this new design, and also it was extremely heavy. We weighed the gantry, and it weighs in at about 110 pounds. That's a little heavy for something that just carries a 5-pound torch. This is an extrusion. It's a standard extrusion manufactured by a company called 8020. 8020 has been around for a long time. It's kind of the erector set of mechanical fabrication. These are 2x2 extrusions. As you see, you can tap the end of it to tie things together. It's got slots in here that you can use to slide in special hardware to be able to tie these things together. You can literally just build about anything out of this. Extremely rigid. On this, we've got a long piece that's going to go across on our gantry. We've got 2 shorter pieces that are going to be mounted. This is going to be cut in half and mounted on the ends on our gantry. So that should lower our profile on the gantry. That should make it a whole lot lighter, and it should have precision motion because of the carriages and rails.